Now we continue with our story of mathematics, and in this lesson we're going to see that mathematics is actually, in general, all based on this thing called set theory. All of mathematics is just different orderings of different sets of things and how we can talk about them. So what is a set? A set is a collection of objects whose contents can clearly be determined. These objects are called elements. A set is often named with a capital letter, which we'll see that part later on. But all you have to know is that a set is just a list of things in any order that you want them. That's all a set is. And even though these videos are online and you can refer back to them, the best way to learn mathematics is to write with your own hand. So please be taking notes as you watch these videos. So what are the ways to write a set? Here is the capital letter line from the definition. A set A could be written as a list. For example, here we have the set of even numbers, 2, 4, 6, 8, 10, onward. You could also write a set using a description. A is equal to the even numbers starting at and including 2. So all of the even numbers with the first element being 2. Or you can write a set in set notation. Set notation here has a lot of symbols that mean different things, so let's work through it. A is equal to x given that, this line right here means given that x is, this symbol means in, given that x is in the natural numbers, x is in n, and x is equal to 2n, or x is an even number, x is equal to 2n, for n in the natural numbers. So what that means is for all of the natural numbers, from 1 to infinity, from 1 to onward, we have these x's such that x is equal to 2n. So if n is equal to 1, x is equal to 2 times 1. If x is equal to 2, if n is equal to 2, x is equal to 2 times 2, or 4. And so on and so forth, and so we end up building that same set that we had before. So these are the ways that you write out a set of elements. Now a set doesn't always have to be just numbers, a set can be anything. So for example, let's write a word description of the following set. A word description of P is equal to Washington, Adams, Jefferson, Madison, and Monroe, which a few of you should be able to tell, but a lot of you maybe not, that these are the first 5 presidents. So we would write this as P is equal to the set of the first 5 presidents. Or we could take a word description, write the following as a list. Set C is the set of US coins with value of less than $1. And we could write this as a list, meaning we have C is equal to, and then we always use these curly brackets, that's an important part of this. Penny, nickel, dime, quarter, and I know there's a 50-cent piece, but I'm not going to write it because I ran out of space. I'll write it down here. And 50-cent, I don't know if there's a name for this. 50-cent piece. So that is our set. Here is the word description, and here it is written as a list. Continuing, we have set notation. Let's write this set notation as a list. A is equal to x, given that x is a month that begins with the letter M. What are the months that begin with a letter M? We want list notation, so we write A is equal to curly brackets, and what's our list? May, March. I think that's it. All the months with the letter M. Continuing, let's do these in list notation as well. Take a minute and pause the video and try them on your own if you would like. The first one says A is equal to x, given that x is a number greater than 10 and less than 4. A number greater than 10 and less than 4. Well, we see there are no numbers that are greater than 10 and also less than 4. So in this case, we actually don't have any elements in this set. We don't have any specific elements in this set. But let's look at this next one. A is equal to x, given that x is a number greater than 10 or less than 4. Now that we changed, all we did was change the simple word right here from and to or, and we went from no elements to, if I wrote this in list notation, I could have A is equal to anything greater than 10. So we have 11, 12, ... or less than 4. So in fact, let's get rid of all this. Let's start with the less than 4. We can go ... comma 1, 2, 3, less than 4, and then we can go up to 11, 12, ... onward. We have all the numbers that are greater than 10 or less than 4. But our first answer has no elements. How do we write has no elements? We actually have an answer for that, which comes in the form of another definition, the empty set. The empty set, also known as the null set, is the set that contains no elements, represented by just an empty curly bracket or a null sign, a sign that means the empty set sign. So, which of the following is the empty set? Which of these answers is the empty set? Take a minute and read through them and make your guesses. I see that A has an element. There is one element in A. That element is 0. There's a 0 in there. 0 is not the empty set. There is an element and it's 0, so this has one element, not no elements. So this is not our answer. A contains an element. If I look at B, B is not the empty set because B is not even a set. There are no curly brackets. So B is not an answer. There are no curly brackets here. Let's read C. The number of students that are going to pass this class. Well, hopefully that's not correct, because if this were the empty set, I would be very unhappy and probably fired. So let's say C is not the empty set. If C were the empty set, that would mean that the number of students who are going to pass this class didn't exist. There weren't any. In fact, even if there were 0, we might end up with a 0, depending on how we define this, which would still not be the empty set. And then we have D. B is equal to x, given that x is a square with exactly 3 sides. Well, there are no squares with exactly 3 sides, in Euclidean geometry at least. So we end up with D being the answer. If you list all the squares with exactly 3 sides, you would get B is equal to absolutely nothing. So continuing on, here is the notation we've been using. This sign right here, this little letter E, this Greek sign, means is an element of. So I could say that basketball is an element of the category sports. Basketball is a sport. Where I could say something that is not a sport, let's say sewing. I don't know if there's competitive sewing, there might be. But let's just say sewing is not a sport. There probably is competitive sewing somewhere, I probably just lied. So this is our notation. These are our 2 symbols that we're going to have to get used to while we solve problems using this set notation. So let's use our 2 symbols here. Are the following statements true? R is in the set of A through Z. Well, I don't see an R there, but I can use my inductive reasoning to say, well, we have A, B, C, and then the ... that probably means the rest of the letters. We have an R is a letter, and they're all lowercase, so even if we're trying to be nitpicky, R is absolutely going to be an element of this set. Or R is most likely going to be an element of this set. Then we have the 7 is not in the set 1, 2, 3, 4, 5, 6. Is 7 in the set 1, 2, 3, 4, 5, 6? Well, there's no dot, dot, dot here, and I don't see a 7, so we'll say that this is not true. Well, this is actually true. Sorry about that. 7 is not in this set, so this is a true statement. And now here's where we get a little bit nitpicky with set notation. We have the set A is the set A an element of the set A comma B. Now, inside of this set, there are not little other sets. The set A is not in the set A and B, the set that contains the letters A and B. So in this case, this one is actually going to be false. Whereas A, just the letter A without these curly brackets, without the set notation, is an element of A comma B. That part is true. A is in A comma B, but the set A is not in the set A comma B. And so this is just some basic set notation. You'll have a few problems to work on to get used to it, to get your own hands on, so please complete those problems. And then in our next video, we will continue on with the set of natural